Have you ever stopped to think about how a multi-billion-dollar NASA mission, the absolute peak of our engineering, is run by a computer that's way less powerful than the watch on your wrist? It sounds totally nuts, right? But there's an incredible and, honestly, mission-critical reason for it. So let's dive into why old school is actually the most advanced way to go when you're millions of miles from home.
Okay, to really get your head around this, just look at this comparison. On one side, you've got your new smartwatch, humming along with a processor that's pushing almost 2 gigahertz. And on the other, the amazing Mars Perseverance rover, a machine that landed in 2021, is running on a chip from 1997 that clocks in at just 200 megahertz. I mean, the difference in just raw speed is absolutely staggering. And this, of course, brings us to the big question. Why on Earth, or maybe I should say, why off Earth, would NASA intentionally pick technology that looks completely obsolete? Well, the answer has nothing to do with saving money or being nostalgic. It's all about one thing: survival. To really get NASA's choice, first, you have to understand the environment they're up against. You see, space isn't this calm, empty void we sometimes imagine. For modern electronics, it is an absolute graveyard. Space is just flooded with these super high-energy particles. You've got cosmic rays zipping in from galaxies far away, you've got solar flares blasting particles from our own sun, and then there are these belts of radiation trapped around planets like ours. They're basically like invisible microscopic bullets flying everywhere, and they just wreak havoc on sensitive electronics. So what happens when one of these particles slams into a normal computer chip, like the one in your phone? Well, in a best-case scenario, you get what's called a bit flip. A 1 changes to a 0 and some data gets corrupted. Not great. Worse, it could cause a single event upset, which could crash the entire system. And in the absolute worst-case scenario, it triggers a latch-up, a deadly short circuit that completely and permanently fries the chip. Game over.
Think about it. You can't just hit reboot on a rover that's on another planet, and you definitely can't send a repair person out there. This is where NASA's entire philosophy comes into focus. When you're in space, rock-solid reliability will always beat raw speed, every single time.
So the solution has a really cool name. It's called radiation hardening. And this is not just some software fix. No. This is a complete redesign of the chip from the ground up. Engineers literally build them differently. They use thicker insulation to physically block particles, they build in redundant circuits so if one fails, another can take over, and they use specialized materials that are just inherently tougher.
This timeline really shows you the insane time lag we're talking about. The chip inside the Perseverance rover first came out way back in 1997, but its trip to Mars took more than 20 years. Years and years of redesigning, brutal testing, and a long certification process before it was even considered ready to go to space.
And that path to becoming space-ready is just unbelievably tough. A chip gets blasted with radiation inside special chambers. It has to run perfectly for thousands and thousands of hours without a single hiccup. It has to prove itself in endless mission simulations. And it all has to be backed by mountains of paperwork. So by the time a chip finally gets the green light, yeah, it's technologically ancient, but you know what else it is? It's functionally bulletproof.
All right, so let's actually meet the hero of our story. This specific, battle-hardened processor that's become the absolute workhorse for some of NASA's most incredible missions.
It's called the RAD-750. Now, it's based on that old PowerPC 750 chip from the 90s, but it's been totally transformed into something way more resilient. This is the brain that has powered rovers across Mars and helped the James Webb Telescope look back to the dawn of the universe.
Now, all that special engineering and testing, it doesn't come cheap. While the chip in your phone might cost, $50? A single RAD-750 processor costs over $200,000 for one chip.
But what do you get for that kind of money? Well, you get a chip that can take 1 million rads of radiation. That is roughly 1,000 times more punishment than the processor in your laptop could handle before it just gave up completely.
And it doesn't stop there. It can also operate in a truly staggering range of temperatures, from a bone-chilling -55 degrees Celsius all the way up to a scorching 125 degrees Celsius. It is built from the ground up to survive the absolute worst that space can throw at it. And this isn't just a one-time thing. This is the strategy. Look at the James Webb Telescope, the Curiosity rover. Heck, even the New Horizons probe that flew by Pluto was running on a chip from 1988. The International Space Station, it uses a processor from 1985. This proven, ancient tech is the gold standard for exploring our solar system.
So you see, this whole thing isn't really about using old tech versus new tech. It's about using the right tech for a very, very specific and hostile job.
It really helps to think about what these processors are actually doing out there. Their job isn't to play games or stream 4K video. Their job is to do a pretty limited set of tasks: navigate, control instruments, collect data, run diagnostics. But here's the catch. They have to do those simple things perfectly, without a single error, for years, sometimes decades.
I absolutely love this analogy because it just nails it. A regular consumer chip is like a Formula One race car. It's unbelievably fast, it's powerful, but it's super fragile. It needs a whole pit crew to keep it running. A space chip, on the other hand, is like a classic Toyota Land Cruiser. It is not going to win any races. It's slower, it's not flashy, but it is unstoppable. It's ridiculously reliable, and it's built to just keep going forever, in the absolute worst conditions you can imagine.
So the next time you hear someone kind of mock old technology, just remember this. There is a chip that was designed in the 1990s driving around on the surface of Mars right now, millions of miles away from home. And you know what? It's doing its job just fine.
And it really leaves you with one final thought, doesn't it? In a world that is completely obsessed with speed and power, what's actually more impressive? Breathtaking speed or just absolute, undeniable survival?